Hi students, for today's notes, we are going to be taking a look at how we add and subtract with polynomials. So just as a reminder, poly, right, that prefix means many. So how do we add something that has many terms to something else that has many terms? And the first thing that we just need to remember is what our rule says when we're adding and subtracting with exponents. So our rule tells us that we are going to add or subtract, depending on the sign, the coefficient, the big number in front, squeeze that in there, and then we are going to keep the exponent the same. So we said if we are looking at something like 4x to the third plus 2x to the third, right, we would take the coefficients, the big numbers in front, and we would add those together. And then the exponent is staying the same, so we're just getting a 6x to the third. So today we're going to be looking at this presented in multiple different formats. So sort of the best case situation is we might be sort of written like a stacked system, where we have x squared on top of x squared, an x on top of an x, and a constant on top of a constant. Okay, if we are in this situation, we are just going to look at what the operation is telling us to do. So in this case, it is telling us to add. And then we are going to do very similar to a system, and we are just going to add straight down. So we're going to take a 4x squared plus a 3x squared, which we know is telling us to take the coefficients in front and add those together, and then to keep the exponent the same. Okay, then as we continue to move on, we'll just go to the next row. Now, the big piece here is to determine the sign, whether we're writing down plus or minus here, is going to depend on what we get when we combine a negative 17x plus a positive 9. So negative 17x plus 9, well, negative 17 plus 9 gives us a negative 8. And then that x is just coming along with it because the exponent stays the same, right? It was a 1, it was combined with a 1, it stays as a 1. Then at the end, we just have numbers that are constants, which means, right, no variable at all attached. And so we're just taking 11 plus negative 15, which will give us a negative 4. And so our final answer here will be 7x squared minus 8x minus 4. Okay, when we look at our next one, we have then the same idea. So very similar here, just making sure that we can combine like terms. So we're saying 15w to the 7th plus 3w to the 7th will give us an 18w to the 7th. We have a negative w to the third, so that's going to be a negative 1w to the third plus a negative 21. So a negative 1 plus a negative 21 will be a negative 22, and then again our exponent is staying the same. And a 12w squared plus a negative w squared will give us a positive 11w squared. And that is just our final answer. Now, we might also have that stacked format, but instead of dealing with addition, we might be dealing with subtraction. Okay, and yes, it is a similar concept that we do just want to keep subtracting each of these terms, but it's the same sort of dilemma we ran into with systems. Doing that as subtraction and keeping all of the signs straight can get very tricky. So instead of actually doing this as subtraction, we're actually going to take this bottom one, the one that follows the subtraction sign, and we are going to multiply it by negative 1. Okay, and what we're truly doing is subtraction, right? We talked about this with systems. Multiplying by negative 1 is subtracting. It's distributing that negative to everything that follows it. So our top polynomial is staying the same. And our bottom polynomial we're multiplying through by that negative 1. So negative 1 times 7 will give us a negative 7y to the third. A negative 1 times a negative 8 will be a positive 8y squared. And a negative 1 times a negative 4 will be a positive 4y. Once we are at that point and we have multiplied through by that negative 1, everything else is the same, and so we can just add these straight down. So this will become a 2y to the third. Okay, this will be a plus a 3y squared. Negative 5 plus 3 is a positive 3. And 2 plus 4 is 6. And then we don't have to worry about dealing with subtraction or any of those other signs. We can just add straight down and get our final answer. Okay, so we will do that same idea for the next one, right? This is subtraction. So if we're multiplying this by a negative 1, we're changing that to addition. So our top will be an a squared plus a 19a minus 10. In our bottom equation, we're multiplying that negative 1 through so that we can really add. So negative 1 times negative 7 will be a positive 7a squared. Negative 1 times 8 will be a negative 8a. And then plus 12. Okay, once we've done that, it changes this to addition. So a squared is really a 1a squared. So 1a squared plus 7a squared will be an 8a squared. 19a plus a negative 8a, or 19a minus 8, will be a positive 11a. And a negative 10 plus 12 will be a positive 2. Now, when we are working through these problems, we want to make sure that we always have our answer written in that standard form. We want it from the largest exponent to the smallest exponent. And that just keeps everybody having the nice, neat, same answer. And that's going to be important as we look at these other problems that we have, because they won't always be stacked and in that nice, neat order for us. So we might have to consider doing some work to make sure we're taking care of that. Now, in this particular problem, we're still dealing with addition, and we are fortunate that we have 2's, 1's, and then constants. Everything is nice and neat. So some of my students even prefer to just move this over and write it right underneath and still treat this like they're nice and neatly stacked. Okay, but the other option is when we know that this is addition, we can just go straight to combining like terms. So we're just going to ask ourselves, is there anything that we can combine with the 6b squared? Well, we can, because we have another b squared over here, and 6b squared plus 11b squared will give us a 17b squared. And then we'll simply just move on to the next piece. Is there anything that we can combine with a 7b, right? To be able to combine it, it needs to have the same base, so it needs to be a b, and the same exponent, it needs to have a 1. Well, we can combine that with a negative 11b, so 7b plus negative 11b will give us a negative 4b. And then if we look at our last piece, right, negative 9 can go with a negative 22, which will give us a minus 31. And so our final answer will be 17b squared minus 4b minus 31. But on the problem over here on the right, we're not as fortunate, and we don't have everything nice and neatly lined up. So we don't have our largest exponent to the smallest, and everything doesn't even necessarily have something it can combine with. However, we are still lucky that we have addition. So if we do still have addition, we can still just go to combining like terms. We might just want to be very careful about what terms we choose to combine when. So to get this from the largest exponent to the smallest exponent, it might help us out to start with the largest exponent that we see here. And the largest exponent that we see in this entire problem is this x to the third. So we will then look through the problem and see if there's anything we can combine with 22x to the third. And there actually isn't anything that we can combine here. So this is just going to come down as 22x to the third. Then we will look for the next largest exponent. So the next largest exponent that we see in the entire problem is 5x squared. There is nothing that we can combine with a 5x squared. There's no other exponent of 2. So that's just going to come down as a positive 5x squared. Then we will move on to our next. Okay, our next largest exponent is we have a 4x, and there is something we can combine with that, which is a negative 11x. Okay, and if we do a 4x plus a negative 11x, that will give us a negative 7x. And then finally, we have a negative 11 and a positive 9, and that will give us a negative 2. And by doing that, our final answer is now in the format where we have an exponent of 3, 2, 1, and then nothing. So our answer is done. There's nothing else we need to do there. If we look at our next problem we're not as fortunate. This is subtraction. We are lucky that these are all lined up in order, but it isn't just simply combining like terms because now we have subtraction happening. So we said if we have subtraction, we are really going to, right, multiply through by -1. And we can see it so clearly when it's set up this way, right? We know that there's really a 1 sitting there, and so that's really truly a -1 we're multiplying through. So -1 times 8 gives us a -8c to the 4th. -1 times 6 will give us a -6c squared. -1 times 11 will give us a -11c. These other pieces are just staying as they are, so I'm just bringing them straight down. Once we do that, we are now back to combining like terms. So it's okay that we don't see the parentheses. Combining like terms, we no longer need them. We took care of them. So now we're just going to look for our largest exponent. So 5c to the 4th, and that can be combined with an 8c to the 4th. And those together give us a -3c to the 4th. Okay, we move to our next largest exponent. A -8c squared minus a 6c squared will give us a -14c squared. And then finally, when we look at our last one, here we have an 11c and a -11c. But 11 and -11 will give us 0, and therefore there's nothing else to write down. And so our final answer is going to be -3c to the 4th minus 14c squared. So we have another subtraction problem in the next one. So once again, we are going to want to multiply this through by that -1 that's sitting here. And so if we multiply that through, we'll get a -5y to the 3rd minus 12y, right? I'm taking -1 times each of these, minus 31 plus 9y squared. Everything else over here is coming straight down. Okay, once we are at that point and we have distributed that -1, everything else just comes down to combining like terms. Now we said we might want to combine like terms in a very careful method. So if we start with the largest exponent, that would be ideal. So the largest exponent I see all the way throughout here is y to the 4th. I don't see any other y to the 4th, so that's just going to come straight down as part of my answer. The next largest exponent that I see is 3. And I do see something I can combine with that. So a 6 minus 5 will give me a 1. I don't need to write the 1, but you could if you wanted to. So plus a y to the 3rd. The next largest exponent that we see will be a 2. And I do see something else that I can combine with that. That's a 2. So once again, a -8 plus a 9 gives me a +1. I do not need to write that 1 down, but I could. My next largest exponent is a y. So 12y minus 12y is giving us just a 0. So there's nothing to write down there. And then finally, I have my -22 and my -31, which will give me a -53. And so my final answer will be 17y to the 4th plus y to the 3rd plus y squared minus 53. Now, the last thing that we're going to take a look at is what do we do if we have one chunk being subtracted and one chunk being added? Once again, the easiest way to handle this is to get rid of the subtraction altogether and just turn it into one big addition problem where we're just combining like terms. So once we get rid of this subtraction, right, we do that by multiplying that -1. We are only going to multiply that -1 into the problems that follow it in parentheses. So this will be a -1 times 6, which will give us a -6a squared. -1 times a -9 will be +9. Everything else I am just bringing straight down. And then just like all of the other problems we have done, we can start combining like terms. So a 4a to the 3rd and 11a to the 3rd will give us a 15a to the 3rd. We have a -6a squared and an 8a squared, which will give us a +2a squared. And then finally, we have an 8 and a 9, which will give us a 17.